Hi everyone, today we'll be presenting the operation of the hopper machine in food processing. To start with some theory, a hopper is a container designed to store and discharge bulk materials using gravitating flow. Essentially, the material moves from the wider upper section down toward the narrower outlet. However, its overall flow efficiency depends heavily on factors like hopper design, particle size, moisture content, loading capacity, and the discharge rate. In real-world food processing, we often run into specific problems with this setup. The most common issues are flow blockage due to bridging or clogging inside the hopper, which lead to inconsistent material feeding. This directly impacts both product quality and production efficiency. On top of that, this blockage causes costly production delays because operators have to completely stop the process just to clear the line. Because of this challenge, our main objective for this study is to closely examine the operation of the hopper machine, observe the flow of the material, and evaluate whether the machine can provide a consistent and controlled feed during food processing.
Safety reminder: always wear complete personal protective equipment before handling any apparatus. This includes a lab coat, glove, hairnet, apron, and covered shoes. This video demonstrates the initial setup for using the hopper. In this experiment, we are using coarse sugar as the material. First, open the top lid of the hopper, then place a funnel on the opening to prevent the material from spilling onto the floor. The material is then poured in slowly and carefully, little by little, until it reaches the desired level. After that, remove the funnel and securely close the lid tightly and properly.
Then we turn on the air compressor to the appropriate pressure to fluidize the material out of the orifice.
Now, we open the 20mm outlet and start the stopwatch at the same time. Allow all the powder to flow out naturally into the tray below. And then, when the hopper becomes empty, we stop the stopwatch and the recorded time is used to determine the flow rate of the sample.
Next, after the sugar fully flow from the hopper machine, we will use a ruler to identify the head of the sugar clump. After that, we will then determine the widening of the sugar clump using the same ruler. Those steps are very important because we will use the data from the height and the widening of the sugar clump to determine its exact degree of angle.
For the dynamic angle of repose, we fill in the transparent container until it is half full with the same sample, and then, while that we close the circular opening using our thumb and then slowly rotate the container to the left until the powder settles and form a stable slope. Next, we're gonna align the container with the protector to measure the angle formed by the powder surface. This is called the dynamic angle of repose, which represents the flow behavior of the powder while it is moving.
In conclusion, our experiment successfully evaluated the flowability of the material through the hopper. We confirmed that physical properties like particle size and shape directly dictate mass flow rates. Additionally, using controlled pneumatic pressure proved to be an effective method to fluidize materials and ensure a consistent discharge, which is critical for preventing blockage in industrial food manufacturing.